Let's say you're going to do it. Do it. All right. That is way time delayed. It's awesome. I think it was recording already. All right, guys. We have the Unit 2B review. These are going to be 5 questions, basically breaking down what is going to be on the quiz, which we'll have in place of a final. Okay. So let's look at this. We're going to have a question like this where we're asked to add, right, rationals. Okay, so expressions. I'm not going to write this out every time. I don't know why I did. All right, so look, here's our problem. X squared plus 9 over 3x plus 6x over x plus 1. Okay, so the main thing with this is, well, you want to look to see, all right, it's addition. Remember, with addition or subtraction, you have to have a common denominator. Okay, so with that, the easiest way to find a common denominator is to look at the two denominators. And if you multiply them together, you know that you have a common denominator. Okay, so what we're going to do is we're going to look over here. And you know what? I'm going to teach this method. I didn't quite teach it this way before. Maybe I'll even give you an easier example. Right? If you have these two fractions, you make 2 new fractions below it. Our new fraction below it is going to have a common denominator. Now, in the same way that the common denominator here is going to be 3x times x plus 1, over here it's going to be, the easiest way to find a common denominator is to multiply these 2 things together, and we're going to have 6 as our common denominator. Okay? And then the question that you asked is, well, how did I go from 3 to 6? What did I multiply by? I multiplied by 2. So I need to do the same to the top. 2 times 2, 4. That way, you know that you've increased the denominator and the numerator by the same value, multiplying by 2. How did I go from 2 to 6? I multiplied by 3. Do the same to the top, 3. And you can see if we reduce these down, 1/2, 2/3 is the same as 3/6 and 4/6. Okay, so what we've done is basically just found a common denominator, and then we would add together the numerators and end with our answer. Okay, so we're just reviewing the 5 concepts that we'll see on the quiz. This is the first one. Let's look at our common denominator being the product of both of them. When I multiply them together, that's the easiest way to find a common denominator. Okay. Now, this is a slightly different method than what we'll see at the last problem, or one of the next problem here coming up. Well, actually, it'll be like the last problem. When we have an equation, when it's equal to something, we have a slightly different method. But this is just the same as when we just add together 2 fractions. Okay, so it's just the method of finding the common denominator. And then here's the deal. We're starting with what's on top. And what I'm going to do is, I'm asking, what did I do to go from here to here? What did I multiply by to go from x plus 1 to 3x times x plus 1? I multiplied by 3x. So I'm going to do the same thing at the top. I'm going to multiply by 3x. You see, I'm just doing the same process here, and it might be helpful. If it's not, and you just know how to do it, then don't let me confuse you. How do you go from 3x to 3x times x plus 1? You multiply by x plus 1. Do the same at the top. X plus 1. Okay. Now, what we end up with on the bottom is going to be that 3x, x plus 1. Maybe we'll combine that in a sec. We'll see. I'm just going to write everything now on the top that is going to be combined. Plus 6x times 3x. Okay. Yeah, it's strange. They didn't talk about restrictions here. But if we go back to the top and we mark our restrictions, let's do our restrictions over here. X can't equal 0. X can't equal -1. Because if I plugged in either of those values, right? If I plug in 0 here, it's making the denominator 0. If I plug in -1 here, it's making that denominator 0. Can't have it. So now I'm going to end up here, and I'm going to do a little bit of work. Let's see, let's do the bottom first. Just distribute that 3x. we get 3x squared plus 3x. And then on the top, it's a little bit more work. We're going to end up with, first, outer, inner, last. Do FOIL to get your answers for this. This top product here is going to be x to the third. That's x squared times x. Plus x squared times 1 is x squared. 9 times x, 9x. 9 times 1, 9. This over here is going to be 6 times 3 is 18. X times x is x squared. Okay. So now we're getting towards the end of this problem. We just have to combine what we can on the top. Keep in mind our restrictions. So I'm just going to write our answer over here so we can circle it out with the restrictions. We're not going to be able to cancel anything out anymore. I'm not seeing that at all. Okay, so we get x to the third. Let's see. 1x squared and 18x squared, 19x squared. And then plus 9x plus 9 on the bottom, 3x squared plus 3x. And then look, I have to circle and put as my answer all of that, because it's not just this final fraction, it's the restrictions as well. Okay, so that's the restrictions. That is our final answer. And this is just adding rational expressions. I'll let you know right now, it's only going to be an adding rational expression problem. You won't have subtraction. All right. I'm going to keep moving. This video is going to be available in the stream. So if you, how about take a screenshot now if you need to get this problem screenshotted. I'm going to go and move to the next problem. All right, let's go to this. You guys will be happy to see this one. You're all no, not happy. X over x plus 1 times 5x over 2x minus 1. Why do we like this one more? It's multiplication. Multiplication, you don't need a common denominator. We do need to state what our restrictions are. And for this problem, that's the hardest part. Because I look here, the left fraction isn't too hard to find. The restriction for that is x cannot equal -1. Because what happens if I put -1 in there? -1 plus 1, 0, not allowed. The left side, the right fraction is a little harder to find. So I'm going to do a little bit of work over here, because really restrictions are saying, when does the expression equal 0, right? It's wondering, when does this equal 0? Some of you can see it. If you can't see it, you can always set it up. Here we're getting our restriction. We're looking for our restriction. Okay, and our restriction is when that expression is equal to 0. So that's why I'm going to go ahead and solve this. 2x is equal to 1. Divide by 2. X is equal to 1/2. So look, that is our other restriction. X cannot equal 1/2. So here's part of our answer. We have our restrictions in there. Because look what would happen if you put x as 1/2 in here. Half of 2 is 1. 1 minus 1, 0. So this was like question mark. When does this happen? We're not finding like a solution with that. This is just finding the restriction. Because the expression was a little more complex, we did a little bit of work to see when does it equal 0. That's the key of why I did all that. Okay. So now we're just going to multiply straight across. 5x times x. I'm in the future. All right, x plus 1, 2x minus 1. Now let's go ahead and get our final answer down here. 5x times x, 5x squared. This is a little bit of FOIL first, outer, inner, last. So we'll go x times 2x, 2x squared. Outer is going to be -x. Inner is positive 2x. I'll write it again. So -x, and then on the inside, 1 times 2x is 2x. 1 times -1, -1. So our final answer is going to be 5x squared. Tell me in the chat if you're confused on anything right now. I'm sensing spider sense telling me. Check. Maybe I'm wrong. All right, look, 2x squared. We combine these. We get plus x. We get -1. We circle all of that. And we're done. All right. Not too bad, right? With multiplication, the hardest part of this was finding that restriction. The restriction just had like a little bit of a step we had to do. So don't worry about it if you have to take that step. If you can't see it, it's no big deal. All right. Next, here we go. Number 3. Number 3 is dividing. So we have x. Oh, wait a minute. Yeah, I'm going to write this different. Why not? I'll put it in there. Start thinking about that. Why was I not sure if I wanted to put that? You have to remember an identity. I won't have the identity as part of the quiz, but I'm curious. Anybody remember that identity? That's equal to something else. Okay, but first, let's put what x cannot equal. X can't be 0. X can't be 0. If it's 0, we're out. X can't be -1. Right? So there we go. We have our restrictions. Done. We'll check at the end if we have extraneous solutions. Actually, we won't have a solution for this. That's coming up. All right, look. This here the x squared minus 9, that is one of our identities, and it is going to end up looking like 2 binomials. Anybody remember what this ended up being? Somebody tell me in the chat. What is this x squared minus 9? That's the difference of 2 squares. What does that end up with? Remember the difference of 2 squares? I know we went over the identities, polynomial identities, really quickly. No one? Okay. X plus 3, x minus 3. That was the identity. I'm not going to make you remember that. That was from another unit. Okay, so now we're going to go ahead and change this problem to be a multiplication problem. We're going to flip the second fraction. We take the reciprocal of the second fraction, and then we can multiply them together. Now I'm looking here, and I'm seeing that this x plus 3 and this x plus 3 can cancel. So when we multiply straight over, let's go ahead and multiply x minus 3 times x. We get x squared minus 3x. And on the bottom, x plus 1. That is the whole answer. Don't forget your restrictions. All right. And I'm not sure based on how I'm doing the quiz, because it's going to be multiple choice. I'm not totally sure if I'll ask for you to answer with the restrictions. But on the written work, I'd like to see the restrictions. In fact, that's all I'm going to look for. When I go look at your written work, I'm just looking for restrictions. Okay? So that's where that goes. And it'll be slight deduction if you didn't put them. Okay, so keep that in mind. What's next? This one. All right. Take a screenshot if you need that for 2 and 3. This page is going away. 2 more problems, guys. I think we'll be done in 10 minutes. Then you can study for all your other classes. All right. 3, 2, 1. All right. How about this one? Where'd you go? Okay. 3. Here's number 4. 3 over 2 plus x minus 1 over x is equal to 1 over 5x. Okay. This is the one where you got to find your LCD, sound system. And when I look at that, let's see. We need some values that all of them will be able to multiply into. This is an expression, excuse me, a quantity over here. So the LCD I know has to have, you know what? That's fine, we'll leave it. The LCD has to have that 2 plus x in it because we need the LCD to be the lowest common denominator, least common denominator has to be able to include all of this, okay? So what I'm going to add to this is 5x times 2 plus x. Because I look at this 2 plus x, that goes into the LCD. X goes into the LCD because it's 5x. 5x goes into it because it's 5x. Okay. Now, what you want to do is you want to next make your fractions with a little more room. You're going to put everything that you had below it, just like before, and everything on top, I guess. But what you're going to then put is your LCD. Now, it's going to cancel out a lot of this. And the reason we're doing this is to get rid of our denominators. You see, because look what's going to happen as I go in my next step. Nope, you're out. X and X, out. 5x, 5x, out. Look at this. We've gotten rid of all the denominators just by using the LCD. Okay. So your question too, if you know, to see if you got the LCD correctly, it's a matter of looking and seeing, is this denominator a component of my LCD? Yes. 5x? Yes. X is there? Yes. So make your LCD include all of your denominators. The least common denominator is what allows us to cancel everything out. So I'm going to go ahead and multiply as we go. 3 times 5x, 15x, minus 1 times 2 plus x is, well, this is why it's a little bit weird. But I'm going to put it like this for a second. Make sure you watch out for your positive negatives. Over here, we have, oh, sorry, this is 5 times 2 plus x. There we go. I forgot this 5 here. Don't make mistakes like me. X over x, so we have the 5 left over. But over here, we only have the 2 plus x. That's what told me that I had done this part wrong. All right, let's go ahead and distribute. We get 15x minus 10 minus 5x is equal to 2 plus x. I'll just combine a couple things at once here. I'm going to make this 10x. I'm going to add 10. So we get 10x is equal to 12 plus x. And now I'm going to subtract x over here. You see, this part is just math 2, math 1, 2. Okay. We're just solving from here on out because we've gotten rid of the denominators. So we just have pretty much like a bunch of, we had this set of equation here. And let me just double check something real quick. Yes, we are going the right route. 9x is equal to 12. Divide. X is, we can reduce this, divide by 3, and we get 4/3. Yeah. Oh my God. And I broke all my rules. Actually, we still have to do the restrictions. Let's go back. We should have done this earlier. Jeez. All right, look, if we plug in 0 here, we end up with 0 in the denominator. How about here? If we plug in -2, we also end up with that. So now we have the full answer. Okay, remember the restrictions are just from the beginning of the problem. What would make the denominator 0? And then also with these equations, you want to ask, is it extraneous? Is it extraneous? Is it extraneous? If I take 4/3 and I plug it in up here, does it make it 0? No. If I plug it in there, does it make it 0? Nope. There? Nope. So it is not extraneous. To see if it's extraneous, plug in solution. Make sure it works. Okay. And if it didn't work, it would be extraneous. If it does work, it's not extraneous. That's why I put not. All right, last problem. We're at 20 minutes. Not bad. Go ahead and finish copying that one down. Take a screenshot if you need it. I'm going to set up the next problem. This one actually is going to take us about 3 minutes. No, you said that. You say that all the time. All right, 1 second. Good. All right. Here's the last problem. And this is a good one because it's... All right, take a screenshot if you need it for number 4. 3, 2, 1. Number 5. All right, so this one is just solving radical equations. Here's our radical symbol. And the key here is, first we have to isolate the radical. Okay, we've got to isolate the radical symbol. Okay, so we need to isolate it. And to do so, how about I subtract 4? Right, that works, right? And now look, we have x minus 1 is equal to 4. Ooh, okay. Okay. Now remember, what is the opposite? The opposite of square root is to square something. Square, square. So now what I need to do is go in here and say, well, you know what I'm going to do to get rid of this radical symbol? I'm going to square both sides. As long as you do the same thing to both sides, it does not matter. It doesn't change the identity of the equation. So we do both, as long as we do it to both sides, we're good. The reason why I isolate the radical first is if I squared both sides, I'd have to include the 4 if I hadn't moved it over. So always isolate the radical first, and then when you square it, there's nothing left over or anything weird you have to do. So look, those are going to cancel. X minus 1 is equal to 16. And add 1, add 1. X is 17. And now, you know what? I'm not going to hold you to restrictions for the radicals. We'll end it. We'll see radicals again. Next unit is kind of intense, I'll tell you. It's kind of intense. But we'll have a couple other things before the end of this unit. It just, with the final, you know, I wanted to do a little assessment here. But we'll come back to this. We'll get more restrictions going when we hit the next unit with radicals. Okay, that's all I wanted to do. So let me stop the recording. Thanks for watching.